And today we are going to be focusing on protein. I hope y'all were able to locate the video on the lipids that I published last Friday or Thursday.
So on our schedule, it says we're going over lesson 5 and lesson 8.
We're only going over 5 today.
There wasn't anything.
That's right. There was nothing on lesson 8, so lesson 5 is what we're covering. Like we say, this is a tentative calendar, so sometimes there will be some deviations from that. And so if you didn't have it, you couldn't bring it to class, okay? So please bear with us with that. Sometimes that happens. Okay, let's talk a little bit about protein. And if I could have your undivided attention, the purpose of class is to learn, okay? And so let's go ahead and let's take a look at proteins. And proteins, they play a vital role in our bodies. They have some specific functions as well that we need to know about. And so therefore, a lot of these will facilitate chemical reactions that take place in the body. They serve as antibodies, and they help with infection as far as fight infection. And it's all right. You don't have to look at me. You know I'm backing you up, okay? And that's not being disrespectful. I'm giving you permission to pay attention to the slides and to listen, okay? Also, it is part of the structure of all living tissue. We are made up of protein. Protein can be in the form of our muscles. It can be have other functions within the body that are not part of the muscles as well. Also, they are comprised as well of carbon, hydrogen, oxygen, but the difference with them is they have nitrogen atoms in there, nitrogen atoms. And the nitrogen component is what is going to make it different, and also the other structures with which the carbon and hydrogen and oxygen are placed. There are 20 different amino acids in proteins. How many of those are essential? Look in the right-hand column of your book on the second page. Talks about essential amino acids. There are 9 of them. And then there are some that actually could be essential, but they're dependent upon the presence of other essential amino acids in order to be made by the body. The rest of the proteins can be manufactured by our body. Okay? Remember that proteins are made up in chains. Bless you. We have dipeptides, tripeptides, and polypeptides. Dipeptides, this is 2 amino acids. Tripeptides, 3. Many. That's many of those that are put together as well. This just shows you the structure of the amino acids there. It shows you as far as with the backbone of it. Up there, it shows you as far as the amino group, the side group, the acid group. And it shows you over to the side different amino acids and the different structures. I don't care that you know this, but I want you to know that they are all made up of carbon, hydrogen, oxygen, and your nitrogen component. They do have the amino group and the acid group, and how those are configured, actually, it depends on what specific amino acid there is. Also, as far as with your structure of your proteins, and I wanted to divert back just a minute to take a look in your textbook on page, on page 121, and remember this is nutrition class. We should have all of our nursing materials put up, okay? And I went back and I told you about some of those that were dependent upon, they were conditionally essential amino acids, and they're dependent upon the presence of other amino acids. Remember the other week we studied about PKU, phenylketonuria? Thank you for letting me share your book. Phenylketonuria. Remember we talked about phenylalanine was not able to be metabolized. And if phenylalanine cannot be broken down, tyrosine, which is another amino acid, cannot be formed. And so tyrosine in some individuals, those individuals who have phenylketonuria, they actually have tyrosine as a conditionally essential amino acid. Why? Because of their condition, PKU, they cannot break down that phenylalanine, and they cannot form as far as with your tyrosine, so therefore they've got to have that. It is essential for them. Many of these proteins, as far as the structures, we mentioned about the different shapes, protein functions. You know, a lot of times the different shapes enable those proteins to perform whatever function they have within the body. And that's why they're formed in that manner. Okay? This shows you as far as with the coiling and folding of that protein molecule. I don't care that you know this. Okay? This just shows you how they attract, how they may repel, etc. So how they can come and join and make other amino acids or other proteins by joining these amino acids together. This is actually the structure of hemoglobin. And this hemoglobin actually, what's the purpose of hemoglobin in the body? To do what? Carry oxygen throughout the body. And so it's essential that we have enough hemoglobin in our bloodstream. People who do not have enough hemoglobin are anemic, or if they do not have enough iron, they can be anemic. And so therefore these people do not get the oxygen they need. Tell me about what kind of patient. How would I recognize that patient? They might be short of breath. They may tire easily. They may need some extra help walking. Those are some individuals who might have some low hemoglobin values. And remember, where iron is here in that molecule, if a person is iron deficient, there will be an affinity for lead to actually migrate here and attach to that molecule. When does that occur when lead attaches to it? What's occurring when lead attaches to that hemoglobin molecule? What kind of poisoning? Lead poisoning. So therefore children who are anemic, actually they will go ahead and draw a lead level on those children to be sure that there isn't lead poisoning occurring simultaneously with that iron deficiency anemia. Okay, does that make sense? Okay, and so that's why individuals who are malnourished or who have iron deficiency actually could be at great risk for having lead poisoning. Okay? As far as with the protein digestion and absorption, very little is going to occur with your digestion and absorption in your mouth. Very little digestion is going to occur. It just mainly moistens it. Once it gets down to the stomach, this is where that pepsin and that hydrochloric acid are going to work on these proteins. It's going to cause it to uncoil. It's going to make it into smaller polypeptides. And so this is what's going to occur. Within your you're fine. Just leave it there. Within your small intestines, this is actually where your enzymes from your small intestines and also from the pancreas is going to work on those proteins. We have proteases that are going to work on that. Proteases work on proteins. How do I know that that's an enzyme? It ends in ASE. Very good. And then we're going to break them down into tripeptides, dipeptides, and your amino acids. And remember that these hydrolyze the peptides, and then that allows the cells to be able to absorb them. Okay, and then they can utilize them. And remember, these are absorbed directly into the what? The bloodstream. Fats, as far as your triglycerides as they're broken down, and they form the micelles and the chylomicrons, they're absorbed directly into what? The lymphatic system. Or there is a lacteal in each of the villi that actually helps with absorption. Very good. Okay, with your proteins, remember that they are going to be broken down, and nitrogen is going to be a component that none of the other nutrients have in it. Okay? So as a result of it breaking down, what's going to happen is the liver is going to break it down, and it is going to form, it's going to be broken down, and it's going to form ammonia. Okay? Then the liver is going to break that ammonia down into urea. Okay? Urea is excreted by way of the what? The kidney. It's excreted by way of the kidney. So therefore, if I do a blood level on a patient and they have a high ammonia level, which organ is having dysfunction? The liver. Because remember, the liver is responsible for breaking the ammonia down into what? Urea. If the blood level is high with urea, what organ is malfunctioning? The kidneys. And so that's what accumulates in the bloodstream. Okay, and that's where you can develop that uremic syndrome. And we'll be talking about that as we go into the kidney chapter. Okay? Okay, we have non-essential and essential amino acids. We've already said essential is what? Made by the body. Do we have to take, non-essential is made by the body. Do we have to take it in by foods? No. Essential has to be taken into the body with food. If we do not eat foods that contain those essential amino acids, are we going to be able to make the proteins we need? No. This is why vegetarians have to have a knowledge about amino acids in certain foods. Otherwise, what could happen? They could have an imbalance. They could have a deficiency. And as a result of a deficiency, the functions normally carried on by proteins in the body are not going to be able to be carried out. Okay? And we already talked about a conditionally essential amino acid. Which one did I say was conditionally essential? Tyrosine. And that's for people particularly who have what? PKU. Very good. You were listening. Okay? And this just goes through and shows how they're broken down. The long peptides are broken down in the short peptides, then into dipeptides, tripeptides, and finally into your amino acids. Okay? And protein is constantly turning over. We're constantly breaking down protein and building it back up. Okay? And remember that we need these amino acids continuously on a daily basis. We're constantly shedding skin cells. We're constantly shedding cells from the intestinal tract. And so the cells that you're made up today are not the cells that you had yesterday. Okay? We're constantly turning them over. Some turn over every day. Some have several-day turnover, etc. Okay? The hemoglobin molecule, well, with your red blood cells, what is the turnover rate for red blood cells? How many days? 120 days, okay? And that's why with this, they can actually check as far as with your hemoglobin A1C for these patients every 3 months to tell what your blood sugar has been. I call it the ice cream test. It does not lie, okay? You can write down all these numbers in that little book you carry in your pocketbook or in your wallet or whatever, but the ice cream test, or that's what I've nicknamed the hemoglobin A1C, does not lie. So it tells us about how much glucose is actually carried on those red blood cells throughout the body. Okay? Nitrogen in should equal nitrogen out. This is with your nitrogen balance. You have a handout on nitrogen balance. I want you to look at it and read through it. Okay? There are some examples of positive nitrogen balance and negative nitrogen balance. First off, nitrogen in equals nitrogen out. That means what we're putting in, actually we're putting out or eliminated the same amount of nitrogen. That's called zero nitrogen balance or nitrogen equilibrium. I think nitrogen equilibrium is a key term. Add the zero nitrogen balance to that as well. Okay? Positive nitrogen balance means that you're taking in more than you're putting out. For example, a normal state when we're doing that is pregnancy and infancy. Why? Pregnancy, we want to take in more protein, and we're taking in that nitrogen in the form of protein, and we're not putting that same amount out because what are we growing? A baby. We're growing a fetus, okay? Now, what about the newborn baby? Think about it. In 6 months, they doubled their birth weight. I'm glad we don't do that. It would not be good, okay? But they doubled their birth weight. What kind of balance are they in? Positive nitrogen balance. Think about the person who is starving. What are they in? Negative nitrogen balance. They're breaking down and putting out more nitrogen than they're taking in. Okay, some of your patients your renal failure patients who have cancer states, okay? Sometimes some of your HIV or AIDS patients may be in negative nitrogen balance, okay? So they're breaking down more than and putting it out more than they're taking in. And also some of those patients that you're taking care of in the hospital who have multiple, like they've been in a motor vehicle accidents and they have multiple fractures and injuries, or the patient who has burns, if they do not consume or are not given a diet to meet their nutritional needs, they could be in negative nitrogen balance as well. Okay? Does that make sense? Okay. So nitrogen is important. Okay? And it's essential that we keep it in check and in balance as well. Okay? It is part of our bones and our teeth and our cartilage and our blood vessels. And this is why when you're helping that patient who has a fractured hip to eat in the morning, and they don't want to eat their protein, their egg, or they don't want to drink the milk, it's not only the calcium, the vitamin D, and the magnesium that they need. It's that protein that's in that milk as well. It's that protein that's in that egg, okay? And remember, if they're a vegetarian, what type of vegetarian would they have to be if they were consuming milk and eggs? A lacto-ovo vegetarian, which means what? They take in milk and eggs in their diet. In your nutrition in practice component at the end of this chapter, it gives you some of those key terms. I want you to go through and familiarize yourself, okay? So for those patients, we may have to look at something different, okay, to make sure that they have their complete proteins as well. Okay, also as far as with enzymes, proteins can be enzymes, and they help to carry on some specific processes. Some of them will break the food proteins into the amino acids, some of those enzymes that we talked about that broke down the polypeptides and broke those down into shorter polypeptides and broke them down into tripeptides, dipeptides, so forth. And then others build long chains of amino acids that actually form proteins themselves, okay? And that just shows you as far as the enzyme, the compound here that is created by these two different components that are attached in there, and they help with that, okay? Okay, also they can be transporters as well. Proteins can be transporters. We already talked about the protein hemoglobin. What about lipoproteins? We talked about that in the lipid chapter. Tell me some names of lipoproteins. I already talked about two of them this morning, or one of them this morning. Okay, LDLs, what else? HDLs, what else? VLDLs, what else? Chylomicrons. If you can't name those off, you have a lot of studying to do before tomorrow. Okay? So those are the lipoproteins, and those help to transport lipids throughout the body and carry out different functions as well. Also, proteins help as regulators. They help to regulate fluid and electrolyte balance, and they particularly keep fluids where they need to be. This is why some of your patients who are malnourished actually will have edema in those extremities. And it's because they lack the protein, and so therefore the fluids are not kept where they need to be. Remember, you have those different spaces where fluids are kept. You have intravascular, you have intracellular, you have extracellular, you have your interstitial fluids as well. Proteins help to keep that where it needs to be. That's why a lot of times patients who are malnourished and particularly lack protein will have edematous arms and legs until you pull back the covers, and then you see they're emaciated everywhere else. Okay? And sometimes that edema can mask the assessment, the correct assessment by the nurse. And protein is the one that's responsible for that as well. This shows you, this is a picture that's in your textbook as well, that shows you as far as with those different spaces where the fluid is kept. Okay? They also regulate fluid and electrolyte balance. We already mentioned that. And remember, these are attracted. Proteins are attracted to water. So therefore, if we don't have enough protein, water or fluid is going to accumulate in spaces where it should not accumulate. It helps with regulating acid-base balance as well, as far as creating a state of alkalosis or acidosis also. And then also antibodies. What do antibodies do? What's the function of antibodies? Pardon? To defend. They keep us well. That's right. When those antigens are present that make us sick and that attack our cells, those antibodies help to protect us. That's why some of these little children over there in some of these war-torn countries or some of these countries that have famine, that have lack of food, a lot of times what may kill them might be a simple case of diarrhea, measles, may end up killing or causing these children to die. Why? Because they don't have enough protein to manufacture those antibodies to protect their body against these attackers. Okay? And so that's why antibodies help with immunity as well. And remember, what do we get? What did y'all have to fill out when you came into the nursing program? Immunization record. And that's what they do. They give you a little bit of these, this foreign substance that are invaders. Sometimes it may be live. Sometimes it may be killed, okay? But it actually helps us to develop those antibodies so that our bodies can defend against whatever we're getting that immunization for. Okay? Hormones, particularly glucagon, insulin, these are some examples. Now remember, all hormones aren't protein in nature. We studied about some of your sex hormones like testosterone or what? Sterols, exactly right. Somebody's been studying sterols with lipids, okay? So therefore, some proteins, hormones are insulin and glucagon. And what do insulin do? Insulin and glucagon do. Insulin does what with the blood sugar? Lowers it. Glucagon does what? Raises it. What organ secretes these? The pancreas. Okay, the pancreas. Glucagon does what? Glucagon triggers what organ to break down? What do they break down? Glycogen. What organ do they trigger? The liver. Somebody's been doing some studying, okay? To break down the glycogen into the glucose, okay? But remember, insulin is secreted, how did we say? It's secreted on a constant basis. And we have a constant secretion of insulin throughout the day until we do what? Eat. Then what happens? Ka-ching! Because guess what? We ate a lot of carbs, okay? And we've got to have that insulin to take care of that, okay? Go through and look at your glucose homeostasis, okay? That was with your carbohydrate chapter. Remember, carbohydrates typically are going to be your primary energy source for the body, particularly your brain, okay, your central nervous system. And remember, if we don't have enough carbs, our bodies are going to begin to create what from the lipids? Ketones. I saw you mouthing it too. Ketones, okay? Ketones are formed from incomplete fatty acid breakdown. And guess what? If we don't have enough carbs for energy, amino acids are going to be used for energy as well. Not all amino acids can be broken down and can actually go through the chemical reaction of forming glucose, but there are some amino acids that can do that. Okay, where are those amino acids going to be taken from? The muscles. Okay, it's not to say, I'm not eating enough protein today. Please take it from this left thigh. No. It could take it from my heart. It could take it from my stomach. It could take it from my bladder. It could take it from my muscles. It is not selective. Okay? And so therefore, it's important for us to consume enough carbohydrates to help to prevent protein from being utilized for energy. Also, starvation causes the wasting of that lean tissue. Some of your type 1 diabetics, a lot of times they will be what? Thin or obese or overweight. They'll typically be thin. Why? Because they may not have enough glucose in the cells to furnish the energy, so therefore they may break down some of their proteins, and also use some of the fatty acids from that incomplete breakdown of the fats in the form of ketones for energy as well. And then Table 5.2 actually summarizes all of the functions of your proteins. Okay? Protein deficiency. Okay, it has a nice little section in here about protein deficiency. Protein deficiency can slow the growth in children. Also, it can actually impair brain growth, kidney function, weakened immune systems, impaired nutrient absorption. Okay? Because with protein deficiency, you know the first organ that is going to be affected? The intestinal tract. Okay? And you know what happens? What are those microvilli? What are they? What kind of projections? They're hair-like, okay? Your microvilli. Your villi are finger-like because they're larger. The microvilli are hair-like projections. What's the purpose of the microvilli? Increase surface area for absorption. Exactly right. And so you know what happens with individuals who have protein deficiency? Those microvilli break off. Tell me about the absorption that's going to be affected. It's going to be decreased. It's going to be decreased. And so therefore, when they're actually giving these, whoever these people are, whether it's children or adults, when they're reinstituting nutrition to them to increase their nutritional status, they have to do it very slowly because those microvilli aren't there. Okay? Also, malnutrition. With malnutrition, you can have PEM, which is protein energy malnutrition, which means there's deficiency of energy as well as protein. Also, you can have SAM, okay, and that's not somebody's name. It's severe acute malnutrition. Sometimes this can occur as far as with specific conditions occurring where they were once nutritionally adequate and now they are not nutritionally adequate. And maybe it's because of famine in a country, as far as droughts, as far as war. Sometimes some of the government officials actually control the food over there. The food may be delivered there. I remember a time when food was delivered to one of these countries and it was rotting on the docks. And the people could not get it because of the control with that. So therefore, you know, that would be severe acute malnutrition. Kwashiorkor and marasmus. And it shows you a picture of kwashiorkor and marasmus on page 127. And this is another picture similar to that. This is your marasmus. Marasmus is total malnutrition. That means of all the nutrients. Starvation. With your protein energy malnutrition, in other words, they look, you know, they're lean, but don't have a lot of subcutaneous tissue, but they have that enlarged abdomen, and that's from the hepatomegaly that occurs as a result of that, and the fatty liver that actually occurs there as well. With some of these, I had a picture one time of some of the children who actually had different colors of hair on their head, and it was because during states of adequate nutrition, their hair had a normal color. During states of inadequate nutrition, their hair actually was almost like completely blonde. I mean, just white blonde. Okay? And so therefore, you can kind of look and see what type of malnutrition is occurring. We already mentioned about the SAM with that severe acute malnutrition. It is going to be rapid weight loss with this. With chronic malnutrition, it is going to be occurring over a period of time. Okay? It may cause these children's growth to be stunted forever, okay? It also could, cause problems as far as with brain growth as well. Rehabilitation, what ways to prevent and to treat malnutrition, as far as making sure they have adequate, as far as with adequate nutrition, balanced nutrition. First, what they're going to do is they're going to restore the fluid and electrolyte imbalances that occur. And then they're going to gradually reinstitute a balanced diet, okay? And it's going to have to be in small amounts at first. Because if you do this all at once, somebody who's been malnourished for months, and all of a sudden you say, here's a steak and potato meal, it could make them sick. Or if you automatically start TPN, which is total parenteral nutrition by vein, if you start it full blast at the rate that it should go for a person that age and weight, you could actually kill them, okay? And that's why in the hospital, as we're going to learn later on, when you start TPN or parenteral nutrition on a patient, you're going to start it out low. And you're going to increase it each day by a liter because you want to be able to reinstitute this slowly, okay? It can actually affect the cardiac and the respiratory system, okay? Okay, as far as with protein excess, we all know that protein, particularly, you can get different types of protein. You can have your lean protein, you can have your medium fat, low protein, you can have your high fat. And typically your proteins are notorious, particularly from animal proteins, as being high in saturated fat. And remember, high diet in saturated fat can lead to what? Can lead to obesity, can lead to actually increasing the risk for diabetes, and also increasing the risk for development of your cardiac disease as well. Kidney disease. High protein diets don't really cause kidney disease. However, individuals who have kidney disease should not be on a high protein diet. Why? What did we say was eliminated by way of the kidney? Urea, which is a breakdown product of protein. And so therefore, if they consume too much protein and they create too much urea, this can actually make that uremic syndrome far worse than it should be. Now, once patients get on dialysis, can they be a little bit more lenient with the protein? Yes. And this could be hemodialysis. This could be as far as with your peritoneal dialysis as well. And we're going to talk about those at the end of this text. Okay? But remember that high protein intake, when there is kidney dysfunction, can actually further exacerbate or worsen that kidney failure. Okay? And so when you have a patient who has diabetes, and you know that they're, they've got to be careful about the amount of protein they take in, because diabetes is actually, along with your hypertension, are going to be the two major causative factors of your renal failure, your chronic renal failure. So that's why we've got to really keep a check on those individuals with diabetes. Protein supplements. Protein supplements, are they good for us? Okay. For some people it might be who actually have deficiency. But should we take these to build muscle? The recommendations are not there to support that. Actually, you could get too much of one type of amino acid that could actually have some severe side effects. Sometimes some of these side effects could be irreversible as well. If you want to build muscle, what is the best way to get your protein from? Diet. And it doesn't have to be a high-fat type of protein. You can use some of the lower-fat types of proteins as well, bless you, that could furnish you with those extra proteins to build muscle as well. Also, I do want you to know about how to calculate as far as your protein intake requirements for individuals. Remember, it's going to be based upon their weight in kgs, okay? So if I would give you a weight in pounds, what are you going to have to do in order to calculate this? You're going to have to convert it to kilograms, okay? Bless you. And here's a way to remember about the 2.2, okay? Miss Goff loves to weigh in kgs. Why? I weigh more than twice as less, okay? It makes me feel good to weigh on a scale that has kgs. Why? Because I weigh more than twice as less. So 1 pound, so 2.2 pounds equals what? 1 kg. Mrs. Goff loves to weigh in kg, so that's where you know that that 1 goes with the kg and the 2.2 goes with the pounds, okay? I don't care if you use that to remember what that conversion is, okay? So you would have to divide that by 2.2. Okay, let's do an example of this, okay? If you got your calculators, let's do that, or if you have your cell phone, you could use that, but only for calculating this. Don't text, don't, Facebook. Let's go on here and do this, okay? Okay, let's go over here, and let's say this patient weighed 160 pounds, okay? 160 pounds. So what I would do first is I would take 160 pounds and divide it by what? 2.2, okay? And then I would end up with 72.727272. Now, what I need to do for every kg, we need what? 0.8 grams of what? Of protein, okay? So multiply that times 0.8, and we get 58.1. Could you do that on a test for me? Yes, you could. Yes.
Would you not round that to 58.2?
You could. But I might round it to 58, okay? So, yes. By the 0.8. For every kg that you have, you need 0.8 grams of protein. Okay? So first, if I give it to you in pounds, you divide it by what? 2.2. Then you get that number and you multiply it by what? 0.8. 0.8. Okay? Now, what if I gave it to you in pounds? In kgs already. Just multiply it by 0.8 grams, and that tells you how many grams your patient needs. Okay? Remember that the American, as far as with the dietary recommendations, bless you, for this macronutrient is going to be between 10 to 35% of your calories per day. 10 to 35% of your calories per day. If I gave you the protein, as far as with the kilocalories, could you determine what the percentage is? You had to do that with the carbohydrates on this last homework project. Go back and study through that, okay? In your textbook, it has a little overview of that as well on page 7. So if you need to go back to that to calculate percentage, you can go back there and look at that as well. Now, what if I gave it to you in grams, what would you have to do first? If it was protein in grams, what would you have to do with that grams? Multiply it by what? Number of kilocalories per gram. And how many kilocalories per gram does protein give you? 4. Okay? So you'd have to multiply by 4 first. Okay? So remember, take that into consideration. Go back and look at that nutrition calculations video if you need to. Okay? Okay, protein quality is going to be very important as well. As far as the type of protein that we consume, it needs to be quality protein, meaning that it has a wide variety of the essential amino acids so that we can manufacture those amino acids that we don't have and so that we can manufacture the proteins that our bodies need. Okay? Also, this high-quality protein is typically going to be easily to digest as well, and so therefore more is going to be absorbed. And we have to take into consideration what's known as the composition of that amino acid as far as, is it a limiting amino acid? A limiting amino acid, that's one of your key terms, is the amino acid that occurs in the lowest amount that actually limits the manufacturing of the protein. And I've got an example up here for you. We're making the protein stop today. That's just a fictitious protein that I'm making, okay? We have our amino acids. These are fictitious amino acids. We have 6 S's. We have 1 T. We have 5 O's. And we have 7 P's. Which is the limiting amino acid? T. T is the limiting amino acid. We know we've got to make stop proteins today, but the lowest quantity is the T. Okay? And therefore, that is known as your limiting amino acid. Does that make sense? If we do not consume enough of those essential amino acids, protein functions will not occur as they should. We will have some of them occur, but it will not occur. We will not be able to manufacture all of those proteins that we need. We will not be able to maintain fluid and electrolyte as far as balance. We will not be able to maintain pH balance. We will not be able to break down nutrients when we consume them because we lack the enzymes. We will not be able to defend our bodies because we lack the ability to make those antibodies. Okay? Does that make sense? So therefore, some functions are going to be left undone. Okay? This just gives you an example of some protein-containing foods, particularly your milk and your milk products, your protein foods as well. When we think about protein foods, we think about, mainly we think about meat, fish, and poultry. But remember, they are high, protein is high in legumes. Proteins can be high in some of your grains as well, your whole grains. And also soy can be a good source of protein also. Remember, depending on how we choose the milk and milk products, we could make it high fat or low fat. Okay? So therefore, if somebody is a lacto-vegetarian, it doesn't necessarily mean you eat healthy. Why? Because you might be choosing all the 4% fat as far as whole milk, as opposed to the lower fat foods. Okay? Also, your grains contain proteins as well. And particularly your whole grains are going to contain more proteins than those that are processed. Okay? Vegetables, some contain some proteins as well. And this is why we can actually combine certain foods, particularly if we are a vegetarian or a vegan or vegan, so that we can have the appropriate number of amino acids. Okay? Also, we already mentioned soy is a good source. Complementary proteins. Complementary proteins means that you have two proteins that you combine in a meal that actually complement one another. What essential amino acids one lacks, the other one takes up on. Okay? And so therefore it complements the other. Okay? For example, rice and legumes, bless you. That is a complete protein. We in the South eat too much protein. I can remember growing up, what did we have a lot of times on Sundays? We had rice and beans. We had meat. We may have had two types of meat. Okay? And then we had all the macaroni and cheese. That was a staple, wasn't it? Yeah. Boy, my mama could make some good mac and cheese. And it's nothing like what you get out of a box, okay? But those are complementary proteins. And that diet, that meal I just described, is way too high in protein if we would eat that for every single meal. But that's what a complementary protein is. This shows you some complementary proteins, legumes with grains, whole grain rice, raw rice. Put them together and you've got all this mixture of these different amino acids. That just shows you how you can do that. Whole wheat bread or whole grain bread and peanut butter make a complete protein. Your milk and your whole wheat cereal, okay, your mac and cheese, okay, and so therefore this can give you your tortillas and, you know, you've got some refried beans in there as well. That can make a complete protein also, okay. Protein sparing, we already said that carbohydrate, a diet adequate in carbohydrate and fat allow for protein to be spared. But remember, carbohydrate is particularly going to furnish a lot of the energy for us. Okay. Also, read on your food labels as far as what percentage of my protein requirement does this food furnish for me. Okay. And I hope you got a chance to look over as far as with that food label video as well. I posted the specific PowerPoint that went with that also, so you could look at that. Vegetarian diets. This is going into that nutrition and practice section at the very end of this, this chapter here. And with vegetarians, there can be different types of vegetarians. If you look, what page is that on? 135. Take a look at some of those key terms there. It talks about vegan or vegan. What is that? That is a person who is we call them a strict vegetarian. They do not drink milk. They do not eat eggs, nor cheese, nor fish. Okay, everything is strictly vegetarian, okay? No meat or meat products whatsoever. Then you have an ovo-vegetarian, which means they're a vegan, but they do consume eggs. And then you have a lacto-vegetarian that they are vegan, but they do consume what? Milk. Okay? And then you have a lacto-ovo-vegetarian, which means they what? Consume both your milk and your eggs as well. And remember with the milk, that includes your cheeses also. That includes your cheeses. Then you can have as far as a partial vegetarian. And with the partial vegetarian, they sometimes include some of these other things. As far as some of certain meats, it excludes and restricts certain meats, but they might include poultry with this. They might include as far as some of these other things as well, your milk and your eggs as well, but they eliminate your red meat. So that's the terms that I want you to know about the vegetarian. Now let's take a look at some nutrients that their diets could be deficient in as well. We need to be sure that they have varied plant protein, because varying plant protein means that we have a variety of amino acids, okay? Also, they need to be sure they have enough energy, because remember, meat plays a big part with furnishing calories for us with our diet. So be sure they have enough energy. B12. B12 is a B vitamin, and they can actually get this from fortified foods or supplements. And B12 deficiency, is it developed overnight? No. How long did they say it may take for you to show symptoms? 3 years. 3 years. And so therefore, these patients, these people who are vegetarians, may not, because primarily your meat products furnish the B12 that you need. And so therefore, they may become deficient, but they may not show deficiency symptoms until, years down the road. Remember, B12 is consumed in the body, but what else has to be present in the stomach in order for it to be absorbed later on? What factor? Somebody's intrinsic factor. Good. It binds to that B12 in the stomach so that later on it can be absorbed in what portion of the small intestines? The last portion. What is it called? The ileum. The ileum. So therefore, not only do we have to ingest the B12, we have to have the intrinsic factor, and we also have to have an ileum in order, well, the ileum's more so over here, but we have to have an ileum for it to be able to be absorbed into. So therefore, people who have different types of stomach surgeries, bariatric surgeries to remove portions of their stomach, they could develop the B12 deficiency as well. Okay? Also, vitamin D. Where can we get vitamin D from? The sun. The sun. You have to stay out there about 15 to 20 minutes. People who are lighter complected don't have to stay out quite as long, but they have to worry about being sunburned, okay, to manufacture the vitamin D. Also, if you wear what? It will limit it. Sunscreen. Sunscreen. If you wear over a factor of 8 sunscreen, you won't manufacture that much vitamin D because it will limit it. Okay? And there can be some other factors as well. If you live far up north, where we're further away from the sun, or there is pollution that is blocking it, it could affect that as well as some other things. Fortified foods can furnish us with what we need if we are a vegetarian. Iron could be deficient because a lot of times iron is majorly found in your meats, meat products. And remember, with iron, where did we talk about we could get iron from and it's not even edible? Cast iron frying pan, and that's called iron contamination. Also, consuming vitamin C could help with some of this absorption as well, consuming vitamin C. Also, as far as with your zinc, you can get this from legumes. You've got to be careful about those binders. What did we talk about binders that could interfere with the absorption of some of your minerals? We talked about, what are they? They're acids. Phytic acid and oxalic acid. And those are binders typically found in what kind of foods? Foods containing what? Containing fiber, remember? And that's why a high-fiber diet could actually have some negative effects on us. So be careful, be sure that they consume a variety of foods with that. Okay? Calcium. Calcium is primarily found in our diet in what? Milk and also dark green leafy vegetables. Okay? And so therefore, if they increase their dark green leafy vegetables, or if they consume legumes have it in there. Fortified foods like your calcium fortified orange juice. Okay, some of your other juices that are fortified with that, and also some of your nuts and seeds. Essential fatty acids, because where do we think about finding your essential fatty acids? Particularly omega-3, in fish. And if they do not eat fish, they're going to have to get it from someplace else. And remember, we talked about flaxseed. I do not eat a lot of fish at all. It's just because that's the way I was brought up. And I got sick on a fish sandwich when I was pregnant with my first daughter. I have not touched a fish sandwich. I was sick. And I was far along in my pregnancy. If you've ever been pregnant and got sick when you are very pregnant, it kind of sticks with you lifelong, okay? But anyway, I don't eat fish, really. There are some types of seafood I do, but not that. And so therefore, I don't take the fish oil because why? It has the fishy taste, especially when you burp it up after you take that. So I take the flaxseed oil supplements. So flaxseed has a lot of omega-3 in there. And so if they consume these oils, these seeds that have that omega-3 in there, omega-6, they can get what they need. Okay? And like we say, vegetarian diets can be health advantageous. It could actually decrease incidence, lower your risk for heart disease or diabetes, because depending upon how you choose your foods. If you stay away from, the meats that are higher in fats, okay, and also control as far as the type of milk or milk products, if you are a lacto-vegetarian, it could be very helpful for you as well. And then remember, your vegetables are full of your phytochemicals. And your phytochemicals, I mentioned those briefly in your lipids video, I believe. And these have some actually functional properties to them to actually have some health benefits for our bodies as well. Y'all look utterly tired, okay? I almost felt like I was talking to corpses out there, okay? But I'm going to let you go today so that you can study. Go home and study. If you haven't read over your study guide, at least look over that, because that's got your information, your major information you need to know. Yes? You can use a calculator. What kind of calculator can it be? The ADN approved calculator. It costs how much? $5. I reckon this will be the best investment you'll make. You'll use this throughout the nursing program, okay? Except in DCT this semester and next. Live for the summer. Yes. Hold on just a second.